Today we're going to move on to chapter 3.3, Simultaneous Linear Inequalities. So I'm just going to go through a few questions. First of all, try 7. Solve the inequalities. So they will give you two inequalities. This is somewhat similar to simultaneous linear equations. So first of all, you will just solve this 6x plus 9 less than or equals to 2x plus 13. And now, because this is called simultaneous linear inequalities, right? So you have to solve them simultaneously. The keyword here is this and here. Right, you must write and. Remember in equation we write or, but here we must write and because x has to satisfy both this and this conditions. So I'm going to move all the x to one side. I'm going to have 6x minus 2x is less than or equals to 13 minus 9. So 4x is less than or equals to 4. X is less than or equals to 1. So if I were to represent this on a number line, reference point 0, 1, x is over here. X is less than or equals to 1. Let's solve the other one. So 2x minus 7x is less than 12 plus 8. So I have negative 5x is less than 20. And that gives me x is more than, because it's divide away negative 5, so you got to change your sign, negative 4. Negative 4, and your x is more than negative 4. The answer lies on where these two lines overlap, which is here. So it's over here. That means your x, therefore your x must be more than negative 4, but it cannot be more than 1. So this is your answer. In try 8, it is slightly more difficult because they do not give you the word and anymore. You have to know how to split this up into two simultaneous linear inequalities and solve it as per the previous question. So we have 5x minus 3 more than or equal to 4 minus x, and 4 minus x must be more than or equal to 7 minus 4x. Now with this and, it makes things slightly easier. You just have to solve these two inequalities together and see where they overlap. So let's move all the x to one side. 5x plus x is more than or equals to 4 plus 3. So 6x is more than or equals to 7. X is more than or equals to 7 over 6. Or 1 and 1 over 6 over here. 4x minus x, because I plus 4x on both sides. Yeah? Plus 4 is more than or equals to 7. Now I don't want this positive 4, so I minus away 4. So I will have 3x more than or equals to 7 minus 4. 3x more than or equals to 3. X is more than or equals to 1. So on the number line with reference point 0, I have 1, I have 7 over 6. Now x is more than or equals to 1, and x is more than or equals to 7 over 6. So where they overlap is this portion here. Therefore, x can only be more than or equals to 7 over 6. Because if x is somewhere within this region, it doesn't satisfy this condition, this inequality, where it's specified that x must be more than or equals to 1 and 1 over 6. So anywhere that within this region, this is not satisfied. You are not satisfying this condition of and. So it can only be where they overlap, and it has to be more than or equal to 7 over 6. Solve the inequalities. Again, split them up into two simultaneous linear inequalities. So solve this first. X plus 1 is less than 2x. So 1 is less than x, meaning x is more than 1. Over here, 3x is less than 2x minus 5. So x is less than negative 5. On your number line, reference point 0, I have 1, I have negative 5. So let's see where all the over. X must be less than negative 5. So over here. And x must be more than 1. So in this case, you notice that there is no overlap. Therefore, x has no solution. There is no way we can find an x that satisfies. There is no number that is less than -5 and at the same time bigger than 1. So no overlap, no solution. Solve for A. Solve this inequalities. So let's split them up. 5x minus 6 and 5x minus 6 is less than or equal to 36. I have here plus 6 on both sides, so 5x more than 0, x is more than 0. Please do not stop here. Even though you see a 0, continue. Make sure that your x has coefficient of 1 only. So you divide by 5. And then 5x is less than or equal to 36 plus 6, 42. X is less than or equals to 42 over 5. 0, 42 over 5. So x is less than here, and x is more than 0. So this is where it overlaps. That means x is less than or equals to 42 over 5, and at the same time more than 0 is positive, and is less than or equals to 42 over 5. So for part B, you have to write down the prime number that satisfies this. So the first prime number will be 2, followed by 3. Now 42 over 5 is equals to 8 and 2. So we can have 5, 7. So these are all the numbers that is less than or equals to 8 and 2/5 at the same time more than 0.